totally, I mean, you get some questions like this. Like this is a pure quadratic formula question.
Hmm.
So do you remember the quadratic formula?
Yeah.
It's okay if you don't. I'm just asking. The problem kind of helps you see it here. Um, one of the things you want to look for is like what is the same, what is different about the answers. And you'll notice that, either this first number, same, second number is different. So that helps you to maybe reduce the answers to them if you know the quadratic formula, minus b plus or minus the square root of b
It
squared.
was either A or B.
Yeah, yeah, it's probably A or B. Okay. So now I mean, it's not that you need to like even write it out. You just have to be able to do the part of the quadratic formula that's different between them, which is the b squared minus 4ac. And they've chosen answers that are both um like kind of the typical sign errors that you will see when you're doing this. Um, so what do you think here? Could you calculate that b squared minus 4ac for us and see what you come up with?
B.
Okay. How did you come up with that? B is minus 7 squared minus 4 times 3 times -1. So really easy to get a sign error. It's either 49 plus 12 or minus 12. It is plus 12, which is 61. Very good. Okay, so um, there is there's not really a trick, to these. There's just if you recognize what's the same, what's different, it helps you. Like there are formulas that help you on the test. This is one of them. You should already know it. But if you don't, it's good to remember that. So here is another kind of pure quadratic formula question. So see if you can use the techniques we've been talking about to work on this, work this one out.
Is it A?
Okay, and how confident are you in your answer?
Confident.
Okay. What did you do? Did you like do the part under the root? Did you do something else? Tell me kind of how you worked through this problem.
I just solved it. I did minus B plus or minus
So
uh
you so you did the whole formula.
yeah, because it was
Okay.
simplified, so I thought I
Right.
had to.
Yeah, I'm just asking because it helps, sometimes if you're going to use the strategies, you can eliminate some errors. Like if you do b squared minus 4ac, 6 squared minus 4 times 4 times 1 gives you 20, which is not in here, but the square root of 20 reduces to 2 square root 5. So that's how you get it down to b and d. That's what I was kind of hoping you would say, something like that, or something like, hey, I did the minus b over 2a, which is minus 6 over 2 times 4 to get minus 3 over 4. And then you got it down to, you said, oh, that means it's not C and not D. Like that's what I was hoping to hear, because that's using the strategy of like doing something, taking a step in the right direction of getting the answer. Now, if you want to use the direct method, you can always do that, but you better do it correctly. Like you better be perfect, because you're then taking the risk that if you make a mistake, your mistake is there. So yes, it is A. Good job on that. Uh, let's look at let's look at this problem here together. So this has the appearance of another quadratic formula. Would you kind of agree with that, the way this is written?
Yeah.
Okay. Do you remember the very first type of factoring that you were always supposed to do first before any other type of factoring? GCF. So sometimes you get a problem like this that looks like it's quadratic formula, but it's got a GCF in there. 3x squared plus 4x plus 2 equals 0. Now, why is this important? Well, if you look at this original and then this part inside parentheses, they have the same solutions. Now, they're not the same graphs. So graphically, it's like one looks like that. Let's just say that's where the x-axis is, and the other one maybe looks like that. Like they have the same intersections, but they're not the same graphs, but they have the same solutions. But the reason this is important is this one is a lot easier to do the quadratic formula on compared to the previous one. So if it were me, I would be looking out for these types of things. Kind of the same approach as before. If you do this minus b over 2a, you should get it down to two answers. Which two answers would you get it down to?
It would be.
It doesn't matter whether you use the original or this one inside parentheses, they both give you the same minus b over 2a.
Minus 4 over 2 equals 2.
So it's either A or B. And then from there, you
Yeah.
can work it out. So go ahead and work it out from there. Just calculate the discriminant, the b squared minus 4ac, and let me know whether it is A or B.
Calculate the discriminant by what?
Well, the discriminant is the b squared minus 4ac. But like you can see the difference. One is the square root of 2, one is the square root of 30 over 3. Um, I want you to come up with the answer now from here. And I'm recommending just doing this part to help kind of determine what is the correct answer.
How would I? Oh wait. Um. Oh, would it be A?
It is A. And for the b squared minus 4c, what I hope you got is 4 squared minus 2 times 1 times 2, which is 8. Square root of 8, well, it's definitely not 30. Like there's no way to get 30 out of that. It could get to
Yeah.
2. And that's what I mean. Like you don't have to solve these things. Like you can direct solve them. You could go and do your normal quadratic formula from here, but that is not the point of this test. And so being a good math student, you're tempted. You're really tempted to do this, but you should not. You should definitely not do that. Um, so let's have you do one without the multiple choice here, just to see where you're at for this. This one I do want you to work out directly, and then we'll look at the question. So go ahead and work this out using quadratic formula, and then we'll look at the question that goes along with it.
So do you want me to solve it like we solved the last one?
Well, there's no multiple choice here, so I want you to just use the pure quadratic formula to solve this. Just work it out the way you would normally do in the classroom.
Um, 5 plus or minus root 11.
Like this.
Yeah.
Excellent. Okay, now let's look at the full question here. And then we'll talk about some other things that they tend to ask. All right, so here is the full question. Keep in mind your answer. What are they asking for? Or what is the value of n in this problem based on what you just did?
11.
It is 11. Okay. So sometimes the problems require you to do the pure quadratic formula. Okay, that's, don't want to get
Yeah.
away from that. Now, the next thing is kind of interesting. So there are two solutions here. So let's take this problem. You get 5 plus or minus the square root of 11, which is really 5 plus the square root of 11, 5 minus the square root of 11. Those are the two solutions. Now, let's say we added these together. What do you notice about the result of adding these solutions together? Or what is the result
It
of adding
equals
these together?
10.
Equals 10. So what happened to the root part?
It cancels out.
It does. Now, do you think that always happens?
Yes.
It does. It always happens. So that's like a little thing where if you know that, you can save a ton of time on certain questions. So the solutions, the sum of the solutions never, ever, ever, ever have roots in them. So like here's a problem where it asks for the sum of all values of n that satisfies the equation. So if you keep in mind what we just said, that when you add the solutions together, there's never any roots, guess which answers it can never be? It can never be those two there. Now that's a really extreme shortcut, but that is something to think about. Um, that helps you maybe on one question on the test. All right.
Okay.
Now, in terms of how to do this one, you might look and say, well, maybe it is a quadratic formula problem, maybe. But you should always look for a GCF. Is there a GCF in this problem? Is there a number that goes into all three coefficients?
2.
2. So it's 2 times m squared minus 8m plus 4 equals 0. So does this have like, can you factor this? And it's like, no. So you do have to use quadratic formula. All right. But you might also notice if you well, I'll have you do this here. So I want you to work out the quadratic formula, but keep in mind there is, well, I probably shouldn't jump to that. Why don't I just have you work out the quadratic formula here for this part and let me know what you come up with. So without that two there.
I used the quadratic formula and I got 4 plus 2 root 3.
4 plus or minus 2 square root of 3 like that.
Yeah,
Okay,
I don't know if I
so
did it wrong or.
4 plus 2 square root of 3 uh, plus 4 minus 2 square root of 3. So like we talked about, those go away.
Oh
So
yeah,
what
so
is
it'd be 8.
it would be 8. Yes, very good. Okay. Now there's kind of a variation on this question. So, we're really tackling square roots pretty hard here, but there's a variation to this question, which is let's see if I can find it here. Where is it? Yeah. So this one is another quadratic formula. And it's kind of like that one where it was like, what was the value of K? Like you need to find K, but you also need N, and then you have to add N plus K. There's no shortcut here. You have to still do quadratic formula, but you're adding N and K together, which ends up being a number um, in this case. So you got to do the quadratic formula just like before and add the results of N and K. So give that a try, please, if you don't mind.
I got I got root 2, and I don't know if I did something wrong.
That's your answer to the quadratic formula.
Yeah,
Okay, what is the value of A, B, and C? And you worked it out.
A is 1, B is -2, and C is -1.
Okay, so the quadratic formula is always like in this form. There has to be a number in front. Like it's not just the root of something. So um it's minus B, which is 2, plus or minus the square root of minus 2 squared minus 4 times 1 times -1, all over 2 times 1. Do you have something like that written down?
Yeah.
Now, very important that when you substitute in parentheses. That avoids some signage problems. So negative 2 squared is 4, and this becomes plus 4. So what I see is 2 plus or minus the square root of 8 over 2. How does yours compare to that?
That's what I got. And then I got
Okay, so
2
you,
plus or minus 2 root 2 over 2.
okay, that's good so far. So that means it's 1 plus or minus root 2. That
Oh,
was good to know.
okay. I just got rid of the 2 instead of substituting with 1.
So it says n square root of p. What is n and p? Like if you look back here,
1
it's
and
n or k. I guess they use k, sorry. N is 1 and k is,
root 2.
nope, k is just the number under the root,
2.
2. And then once you take n minus, wait, did I check here? N plus k. Could be. That's 1 plus 2, which is 3. So there's in the free response portion where you have to grid in some answers. A lot of times we get caught up in thinking they're really sophisticated. They're not. They're often very straightforward numbers. Like, so if you're going to guess something in the grid, zero is a good answer, one's a good answer, kind of anything. These are all good answers. Like, don't just leave them blank. I mean, put something down, but you can see it can't be root 2 because you can't grid in root 2. There's just no way to grid that in. All right, let's look at
Mm-hmm.
a more challenging question here. Um, so a lot of times you get a question that looks really super difficult, but if you use the strategies we're talking about, you have a chance of at least getting it down to 2, where you can then make a decision. So this should be in the form x squared minus k over 2x minus 2p equals 0. A is 1, B is minus k over 2, and C is minus 2p. You agree with that? I've set that
Yeah.
up. So if you just do minus b over 2a, you should be able to eliminate 2 of the answers. So I want you to do that. Do minus b over 2a and tell me which 2 answers you can eliminate, please. Or which ones it could be. Either one's fine.
It's not A.
Wait, give me, what is the minus b over 2a? What does that become? I mean, this is what I'm seeing. It's minus k over 2 all over 2. What
Um,
does, it's like the negatives
2K
cancel, you get
over 2.
k over 2, and then you multiply by the reciprocal, top and bottom. So it becomes k over 4.
Oh, okay.
So that eliminates C and D. Now, what is the difference between A and B now?
Um, minus 2X. I mean, 4A, the minus 4AC part.
Yeah, probably. We can maybe we're looking, but basically it's whatever this is now. So at a minimum, you have a better chance of guessing if you're down to 2. Now, I'm not saying that that's easy, but you can do this minus k over 2 squared minus 4 times A times minus 2p. Now, again, I'm not saying this is like easy. I'm just saying that you can kind of look ahead here to see what you get. So this first one is k squared over 4 plus 8t, okay? And if you make a common denominator here of 4, how does that affect this up here? When you make this 1 into a 4, what happens to the numerator?
You multiply the numerator by 4.
Right. And that's going to give you the 32p, which is why B is correct. You don't need to
Okay.
really justify it. Again, there's no work. You just have to get to where you kind of can see it. Um, it's not like your tests in the classroom. Okay, so as a quick reminder here, the discriminant, which is b squared minus 4ac, there's three possibilities. If the discriminant is greater than 0, there are two real solutions. If the discriminant is equal to 0, there is one real solution. It's called a repeated root. If the discriminant is less than 0, there are two complex solutions. Do you remember seeing this at some point?
I think, yeah.
Okay. So there is like the chance that you get one question where you have to rely on this, where when I snip it in, you'll see what I mean. It says for this quadratic equation shown b is a constant, and if it has no real solutions, that means this also means 0 real solutions. So basically the discriminant is less than 0. Okay, which of the following must be true? So what they're asking you to do is essentially find the discriminant, the b squared minus 4ac, and set it less than 0. Um, so could you attempt to solve this? You probably see pretty quickly it's not c and d because there's no b squareds in there, but a and b you can get it down to.
A.
So we got 4 times 3 times 5, which is 60. B squared has to be less than 60. It is letter A. Okay, so that kind of concludes everything on like quadratic formula that you might need to know for this for this. Okay, let's look at systems of equations. It's okay, we'll just switch to a new topic for the rest of the lesson. All right, so a system could be more than two. You might think, oh, I already know this. Doesn't have to be two. Could be three. Doesn't even have to be linear. These are, this is a circle, this is a quadratic, this is a line. There's a system of three equations and their graphs in the xy plane are shown above or to the left. How many solutions does the system have? So this is really testing your knowledge of like, what does it mean for it to be a solution graphically? And it's okay if you don't know, but I can give you some background on this.
Um, and then if it crosses one of the axes, it's a solution.
So they were talking about the system being a solution to the system. If you're looking at just one equation, that could be true, but we're looking at all of them together.
It has two solutions.
Okay, what is the first solution? Ordered pair.
Y
Or
equals x squared minus 3.
no. The solutions are an ordered pair, some sort of a place where they like intersect. So I'm asking what is an ordered pair where they intersect?
Um,
Okay, so I can tell there's some confusion. Let's go
2,
back
1.
to, yeah, so let's go back to like two lines. That's the solution where they intersect. So you're saying 2, 1. Let's take a look here. I agree. That's two. That is one of the solutions. What is, you said there was two. Where is the other?
-1, -2.
Very good. Now, why is this place right here not a solution? What's wrong with that point there? What's wrong with A?
Because it's not the other line intersecting with it.
That's right. They have to all three intersect. And I don't know why that's unclear, but it really is important. They have to all three intersect at the same place. So that's really good. Really, really good. Okay. Um, so let's talk about two lines. I have it here. So that's point A. Here's point B. Here's point C, and here's point D. So A is the solution. Would you agree with that? Like that's where they intersect.
Yeah.
Let's call this line 1 and this line 2. What can you say about B? Point B. What can you say about point B?
Uh, it's
I'll take anything.
point on the line.
Right. So it's a solution to L1, like it's on the line. How about
Hmm.
C? What can you say about C?
C is solution to L2.
Yes. So it's on line 2. What about D?
Not a solution to either.
Yeah, it's neither on L1 or L2, which could be problematic. I mean, possibly. So next thing here to think about is we have how many solutions to this when there are parallel lines? How many solutions are there?
None.
None, zero. How many solutions? And then we just talked about this. There is one solution to this. And what if they are the same line? How many solutions are there then?
Infinite.
Yes. These are the only possibilities. There's nothing more, nothing less. You could do the same sort of analysis with like parallel lines, like you could have a point on the line, on the other line, or not on them. That's another possibility. Any questions on that before we move into some like actual systems?
I don't think so.
Okay. So you do get questions where they literally ask like how many solutions does it have? And what you don't do is you don't graph it. You try to figure out something else to be able to answer it. This is probably not the calculator section. So you have um, you have two equations here. There's no way it's C. That's why you always look at the answers. Sometimes something, you know, it jumps out. You're like, oh, well, it can't be two solutions. That's ridiculous. Um, could be zero, could be one, could be infinitely many. So what's kind of your approach here to solving this? What do you think?
Um,
How do you remember how to solve systems?
I would. I'm not really sure.
All right, so there's three approaches that they talk about in the classroom typically. There's more than three. The first is graphing. You're not going to graph these. No, you're not doing that. Second is substitution. Third is elimination. Do you remember any of those?
Yeah. Oh yeah.
Okay. Okay. You're not really going to do either of those in the SAT because it takes too long. So what I want you to do or see here is, and let me have you see how if you divide this second equation by 2, you get 2x plus y equals 10, and 2x plus 6y equals 2.
Mhm.
Okay, that part's okay. So we're going to go back
Yeah.
to this picture. Parallel lines have the same slope, but different b values. Okay. Infinite solutions has same slope and the same b value. Intersecting lines have different slope. 100%. So what is the thing you should find in each equation to maybe answer this question? Like what would be really useful to know based on what we just said there?
Whether or not they intersect.
More specifically, the slope. If you know the slope, if they're the same, it's either 0 or infinite. If they have different slopes, you know that it has one solution.
Okay.
So the slope tells you everything. Now, notice you don't even need to calculate the slope. You just need to know whether it's the same or different. And I don't know if you can do that by just looking at it, but do you think that has the same, these two equations have the same or different slope?
Different?
They do, which means the answer is B. Now, I don't know if you're comfortable with that. Like I know as a student, you're like, ah, I gotta get a number, gotta get a number. But if you can do this kind of like analysis where you don't actually get the number, you're just like, ah, they're different, oh, they're the same, you will much more quickly be able to answer these questions.
How do we know it's not C again?
Two lines only intersect either 0 times, 1 times, or infinite times. And these are both lines.
Okay.
Like I find it a really fun exercise to ask students to figure out like how many times can a circle and a triangle intersect, where you can change the ones of either, right? Like you have to be comfortable with the idea like, okay, a line and a parabola could be twice. A parabola and another parabola is twice. A circle and a parabola could be 4 times. Like there's all these different intersection possibilities, but with lines, which is the one you see mostly, it's either 0, 1, or infinite.
Okay.
If you need more explanation, please just say so. I'm happy to further.
No, that makes sense.
Okay. This is a similar problem, but it doesn't have any y's in there, but you need to treat it like this is line 1 and this is line 2. So again, there's no possible way. There's no possible way it can intersect 2 times because they're lines. Now you just need to figure out if the slopes are the same or different. And so you really just look at them separately. You're like, all right, what's the slope of this one? What's the slope of this one on the left? Are they the same? Are they different? That will help you to answer this. Is it clear what I'm asking, or do you need some more
Could you
explanation?
explain it a bit more?
Yeah. So like the one on the right is really y equals 3x plus 4. The one on the left is really 10 minus 3 parentheses x plus 2. And you know from your classroom experience that it's mx plus b. So the slope on the one on the right is 3. You have to manipulate this one here to figure out the slope. Like you should distribute the -3 in, combine like terms to come up with the equation. So I'd like you to do that. Give me the equation for y here.
Equation for Y?
Yes.
It's already there, the 10 minus 3 x plus 2.
Okay, then Okay. I don't know why we keep just kidding. I want the slope here. I'm trying to I gotta distribute the -3 in, combine like terms. Like I'm
Oh,
asking you for it in this form so that you can tell me the slope. Because right now you don't know the slope or you can't see it. That's okay. Like
y
you just have to
equals
write it.
minus 3x plus 4.
Okay. What is the slope?
4?
The slope is the number in front of x,
Oh,
always.
minus 3.
Okay. So you got lucky there because they are different. Like even if you said 4, they have different slopes. So how many solutions do they have?
1.
One. Oh, got it. Okay. Um, so notice that you maybe could have figured out the slope by just looking at it because the slope is the number in front of x. When you distribute the -3 in, there's only one x. So keep that in mind for the next question. Like you really want to determine the slope of each line. I know they don't teach this in class. Yeah, I get it, but that's really how you do this. This is the fastest way to do it correctly. So um, look at the look at the equation on the left, look at the equation on the right, determine the slope of each.
X squared.
What is the slope of the one on the left? Slope on the one on the right, whenever you got it.
The slope on the one on the left is 3, and then the slope on the one on the right. I don't know how you get it because there's an x squared and then the.
There's no x
Oh,
squared. I mean,
no, it
again,
would just be 1, right? The
you
slope.
do have to distribute the 2 in, combine like terms.
Oh, wait, never mind. I like distributed it a different way. It would
Okay.
be 3.
Okay.
So
So
then,
that's different. So now we go back to our reference here is if they have the same slope, there's two possibilities. They could either be parallel or they could be the same. If they have different b values, they're parallel. If they have the same b values, they're the same. So now you got to go one step further. And I know the equations are the same, so you can already make that determination, but the b value is -8 in both, which means that they're exactly the same, which means that there are infinitely many solutions.
okay.
So if they have the same slope and they have the same b value, that's infinitely many solutions.
Okay.
Something happened here. My snipping tool just caused my thing to crash. All right. Um, all right. So this is kind of the same question because it's now leading you to, okay, it has infinitely many solutions. If the equation has infinitely many solutions, that means the slopes are the same. So you have to find the slope of the one on the left, the slope on the one on the right, and they should be the same. So the one on the left is 4x plus b over 2. The one on the right is 2x plus 8. Are the slopes the same?
16. D.
Okay, so you give me the final answer. Yes. So the slopes are the same. And then what has to be the same is this next part, and you correctly indicated that 16 divided by 2 gets you to 8. Very good. Okay. So that's a like there's these little shortcuts, if you know your math, like you have to know this stuff. You have to say, okay, like different slope, they intersect. Great. Same slope could be one or the other. You got to know the difference. All right, that is going to do it for us for today.